Now, did you know that our sun is actually green? Okay, I'm kidding. But in reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious, can't you tell? In fact, our sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the sun yellow? Yep, it's yellow too, but please don't stare at the sun just to make sure. It appears white when we see it from the International Space Station. This is the sun's real color as our eyes perceive it. The sun gets a yellowish hue when its rays get scattered in Earth's atmosphere. Our atmosphere doesn't let the blue rays of the spectrum pass very well, but the red ones? Hey, sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays? Nope. Red rays? Anytime. So you probably already guessed what would happen if the sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky. Orange water and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad. Oh, by the way, one day, the sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But it's not going to be so much fun for us. So let's hope we won't be around to see that moment. I know I won't. Hey, I've got a party to go to. Okay, now, what if the sun was green? Well, the truth is, the sun is green. So here's your dialogue.
Wait, are you kidding me? Didn't you just say that it's white?
Ooh, good job on that, by the way. Well, not exactly, bud. The sun just looks white, but technically, it has a temperature of around 10,000 degrees Fahrenheit, and the pink wavelength of the sun's spectrum corresponds to the green-blue hue. But to make sure that the sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what'll happen then? Well, everything will be green, and everything will also be a bit darker. Well, face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They're called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot, blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it by hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference. And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off of it. Now, the only thing we still have to illuminate our nights are stars, but they don't help us much. Good thing this scenario is totally unrealistic and there are no black stars, right? Well, yeah, there are no black stars, and still our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs, maybe even seven dwarfs. When a star like our Sun is about to finish its life, it expands and turns into a red giant, and then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, it turns into a black dwarf. But you've probably never heard of them. Why? Because, surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory. And it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now. Well, that's a myth. They're all still alive. Why am I telling you all this? Well, let's imagine that our Sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The Moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume we're still alive. Fortunately, we wouldn't freeze instantly, as you might think. Earth's core has its own temperature, more than 9,000 degrees. But the temperatures on the surface of the planet would still immediately drop to 32 degrees Fahrenheit. The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be minus 190 degrees, and in a year, it would reach minus 450 degrees. Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze very quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? Well, first of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people. But we would still be able to survive. We'd have 2 options: to build giant submarines and go down into the depths of the ocean closer to Earth's core, or stay on the surface, living our lives in some location where we'd have sources of geothermal energy. In Iceland, for example. We could also settle near volcanoes. Their heat would be enough to warm us for a long time. Our vision would adapt to the dark, but at some point it would reach its maximum. So we'd need to get used to living in complete darkness. But who knows? Maybe we would adapt to this life too. So, which option would you prefer? Living at the bottom of the ocean in a submarine or on the surface near volcanoes?
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, flop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the Sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the Sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The Sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst-case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the Sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are 2 stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These 2 aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun, so its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun, and if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny. It's becoming colder by the minute. The temperature drops below zero very quickly, and although there's no snow, the cold is becoming unbearable. Hoarfrost appears on the ground, the grass, and the trees, and ice forms on bodies of water at an incredible rate. Shivering people all over the planet raise their eyes to the sky, and their jaws drop in disbelief. The Sun has become twice as small as it used to be. It now looks like a distant speck, and it won't be able to heat the Earth any longer. But the worst thing is, there's a huge blazing rock coming right at the horrified spectators from the sky, and the impact with that thing will undoubtedly do a lot of damage. Okay, let's go back to our objective reality. The Earth is exactly in the sweet spot of our solar system. It's neither too close nor too far from the Sun, making the temperature on our planet not just tolerable, but rather pleasant. Scientists often call Venus, the second planet from the Sun, our Earth's evil twin, because it's so hot and inhospitable that no life is possible on it. Of course, there are thick clouds in its atmosphere that rain acid, and the greenhouse gases raise the temperature on the surface to unbearable values. But even if Venus didn't have those, nothing would still be able to live there because of the proximity to the Sun. If there was any liquid water, it would evaporate too quickly, leaving life no chance to develop. On the other hand, Mars, going next in line after Earth, is a bit too far away from the sun, which makes it cold and lonely. The temperature on its surface is below freezing, and it never warms up enough for water to stay liquid for long. That's not to mention the lack of atmosphere on the red planet, the element that provides the Earth with breathable air. So, if our planet shifted closer to or farther away from the sun, its temperature would either rise or fall respectively. A few hundred miles wouldn't make much difference. The circling of Earth around the sun is uneven anyway, and we constantly get nearer to our star or fly a bit away from it. The distance that would matter is measured in millions of miles. And yeah, just like I showed you at the beginning of this video, we'd see the sun a lot smaller than we do now if we went that far. The temperatures might not fall at the exact moment of the shift, as there would still be some warmth left. But in the following winter, our planet would probably stay cold forever. The oceans would be covered with ice, and the overall sea level would drop. And ultimately, the ice would reflect more of the sun's heat back into the atmosphere and space, not allowing the surface of our planet to get the necessary warmth. And more ice means less water vapor in the atmosphere. Water vapor captures heat too, creating clouds. So the colder it is, the less rain. The cold and the lack of rain would not let any plants survive for long. So the areas of icy and barren landscape would grow fast, leaving only the areas along the banks of rivers intact for a while. After some time, the rivers would stop running too, either frozen or dried out because of losing their sources, lakes and seas, which would, of course, freeze as well. Any life dwelling near them would disappear. Plants first, and with them, everything else, since plants produce both food and breathable air. And with that, the Earth would become a frozen wasteland. As for the giant blazing rock I mentioned, it was an asteroid coming from outer space because of the shift of our planet's orbit. Jupiter, the largest planet in our solar system, acts as a natural shield for us against space rocks. It has a huge mass, and most asteroids flinging from outer space get caught in its gravity and fall on its surface. There's no life possible on Jupiter, and its surface is gaseous, so asteroids tend to disappear in it without a trace. Still, some manage to get past Jupiter, where Mars comes into play. It also contributes to our defense by holding the asteroid belt between itself and Jupiter in place. The two planets' combined mass creates a gravitational field that doesn't allow the asteroids from the belt to fly in random directions, hitting everything in their path. If there was no Mars between us and the belt, we'd be used to meteor showers almost more than actual rains. Say the Earth has replaced Mars in its orbit, and now we're hundreds of millions of miles farther away from the Sun. The mass of the Earth is more or less similar to that of Mars, so the asteroid belt is still in its place. The temperatures will still fall though, and life will soon go extinct. But if Mars stayed where it is, and the Earth just shifted away, it would be a recipe for disaster. There's no chance the planets would orbit the Sun at the same rate because their mass is not equal. At some point, they would collide with each other. Taking their speed into account, they'd both crack and shatter, perhaps creating another asteroid belt in our solar system. It would be no more hopeful for us if the Earth decided to jump closer to the Sun. Apart from the star seeming more like a giant, pitiless, blazing ball in the sky, its heat would melt the glaciers on our planet, making sea levels rise abruptly. The water would flood major parts of the continents, and more surfaces of the planet would be covered with water, which means more heat absorption. That would bring about a further rise in the temperature. Also, those large bodies of water would evaporate like crazy, releasing tons of water vapor and carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas that absorbs heat, and so does water vapor. Together, they would trap more and more of the sun's warmth, creating thick, roiling clouds in the sky, almost like on Venus, but without the acid. And that thick blanket of clouds would also contribute to heating the surface of our planet. In the end, the entire Earth would heat up so much that life on its surface would become unbearable for most. Only the sturdiest of creatures would be able to survive temperatures so high, those that dwell in our deserts, for example. Despite the rainfall, which wouldn't cease as in the cold scenario, plants would still have difficulty adapting to the new and hot environments. The ones in the cooler regions of the planet would be the first to wilt and go. But then, plants from the moderate and finally tropical climes would also give up. And, yet again, the Earth would turn into a barren ball of rock, only this time an overheated one rather than frozen. Our planet's distance from the Sun, its tilt, its speed of rotation around its own axis, its orbit around the Sun, and even the presence of the Moon in its skies, all of that is crucial for life on Earth to exist. For instance, if the planet wasn't tilted relative to the Sun, it would be unbearably hot on the equator and impossibly cold at the poles. The seasons would also stop changing, dividing the Earth into strips of endless summer and winter. Our planet is heated up evenly from all sides with the current tilt and rotation, like you would roast a barbecue. It turns to the Sun with one side to warm it up, while the other cools down during the night. Were there no change of night and day, we'd probably only live in some areas of our planet where constant, never-ending twilight would be. Just imagine our life without those beautiful sunrises and sunsets. Maybe we'll just let it stay as it is, okay?